Okay, so many of these will be easy. So chapter 11a, this first example is not too bad. The only thing that's new is question C. And what you need to remember is when you derive 10x, okay, the answer is sec squared x. Remember this? It's from unit 3.
Yeah.
Yes, it's from unit 3. So when you derive 10x, you get sec squared x. And what's sec x?
What do you mean?
What is sec squared in terms of sine cos?
Oh, I don't know. Cos, sine over cos?
No, it's 1 over cos. Sec is 1 over cos, so sec squared is 1 over cos squared x.
Okay.
Okay?
We derive it.
Wait, yeah, well, sec squared is 1 over cos squared x.
Oh, so yeah.
Okay? Because sec x is 1 over cos. Just remember, sec is 1 over cos. Just remember that. It's just a quick note, right? Sec is 1 over cos. Cosec is 1 over sine. Okay? So when you antiderive sec squared 2x, remember when you antiderive a linear function of x, right? Question C. From 0 to pi on 8 of sec squared 2x dx, right? So this one, when you antiderive a linear function, you always divide by the coefficient of x first. Yeah? And then you antiderive sec squared of that, that would become 10 of 2x.
Yeah.
Yeah, because when you derive 10, you get sec squared, so that will be that, and then from 0 to pi over 8.
Yeah.
Yeah, make sense?
Yeah.
Then after that, just sub in the values. So sub it in would be 10 of 2 times pi on 8 is pi on 4. So 10 of pi on 4 minus 10 of 0.
Yeah.
Yeah, the rest is easy, right? What's 10 of pi on 4? Is the triangle thing. 1, 1, root 2. Pi on 4 is this, 10 of that is 1. So that'll be 1 minus 10 of 0 is 0. So remember, recap, tangent. How do we find out tangent using the unit circle? The tangent line on the right hand side. Remember this?
Yeah.
Yeah? And the unit circle has the sine and cos axis, and the tangent axis is the tangent. Right? So tan of 0, where is the 0 angle? 0 means it goes nowhere, it just stays here. So the point on the tangent line is also 0. Right? So remember sine cos, that's 1, negative 1. So corresponding value on the tangent line would be 1, and corresponding here would be negative 1. So the tangent of an angle is where it meets the tangent line. So let's say this angle is negative pi on 4, right? Negative 45 degrees, yeah? Yeah? And negative pi on 4, if you were to extend this line, it will meet the tangent line at negative 1. Therefore, so this point is represent tangent of negative pi on 4.
Yeah.
Okay? Make sense?
Yeah.
Yeah. So again, this is recorded. If you forget it, just go back and rewatch it.
Yeah.
So that's question C. Now question D. How do we do something like this? Question D here. Antiderive from 0 to 1 of square root of 2x plus 1. How do we antiderive something like this?
Put in brackets, go to power half.
Yep, put in brackets, power half, right? And then when you antiderive power half, what would that be?
2.
No.
Wait, what do you mean?
You add 1 to the power, you divide by the new power. Okay, so you add 1 to the power plus 1, and that would be 3 on 2, right?
Yeah. And then
You divide by 3 on 2, which is times by
2 on 3.
times by 2 on 3. And whatever is in here is the same. But because this is a linear equation, you also have to
Chain rule over this or times?
times by 1 over 2. Remember, you divide by the coefficient. When you antiderive, you divide.
Yeah.
Remember that? Yeah. When you derive, then it's chain rule. But when you antiderive, it's you have to divide by the coefficient.
Yeah.
Okay. So then that would and then that whole thing would be between 0 and 1. Right? And then 2 and 2 cancel off. Take the 1 over 3 out of the bracket, so it looks something like that. Yeah. 2x plus 1 power 3 on 2 from 0 to 1. Okay? Keep the constant factor out of the front. It's just sub the values in. So sub 1 in, you get 2 plus 1, which is 3 to the power 3 on 2. And then minus 2 times 0 is 0, plus 1 is 1, to the power anything is just 1.
Yeah.
Okay? So that would be 1 over 3 times by So 3 to the power 3 on 2 minus 1 over 3. Why do I multiply it in? Because I can simplify this. What would I simplify to?
The threes, and then make it 1 times 3 on 1. Well, times 3 to the power of 1 on 2.
Yes and no. Yes, you can do that, but the easier, no, because there's an easier way. Change that to power minus 1. How do you combine two powers?
You just add them.
Yeah, so that would be 3 power 1 half.
Yeah.
Right? Because it's 3 over 2 minus 1, right? So it should be 3 over 2 minus 2 over 2, which is 1 over 2.
Yeah.
Yeah? So that'll be 3 power 1 half minus 1/3, which is square root 3 minus 1/3.
Okay.
As a exact answer.
Alright.
Okay? Make sense?
Yeah.
Okay, so everything makes sense so far? That's only because that's the easiest part. Now, let's see what the next question is like. The modulus function. So this one is not too hard. Modulus just means if you get negative, you just cancel out negative. We did this before. Okay? But you're officially learning that in specialist now.
Yeah.
Okay? So just do that. The example, this is actually not too bad of an example. It's just straightforward. For example, question A. Let's just use the answer for this example. This is the easy stuff. I need to get to the hardcore stuff in a sec.
Yeah.
Okay, so absolute value, when you get negative number, it just turns into a positive number. It's just the distance from 0, right? The distance of the number from 0. So it's just basically cancel out any negatives. Okay? And yeah, so when you have something like that, you would work out the absolute value of -4, which is 4 on 2, which is 2. So when you have absolute value around a certain thing, the answer will always be positive. Right? You have to evaluate whatever's inside it first, and it will turn into a positive. Okay? Okay, alright. Now, the reason why you need to learn that is because of this. The function y equals to ln of absolute value x. Remember how you learned in the past that ln of something, whatever is in that ln, cannot be negative?
Yeah.
Yeah? And it makes sense. So in this case, in specialist, you are learning a special version of ln, which is ln of absolute value x. So normally, the ln graph doesn't have that part, right? Normally. But if you have absolute value of x, then it turns everything, every x value, regardless of whether positive or negative, into positive. Right?
Yeah.
Which means you can have this section here. Right? It just means that when x equals to, let's say, -1, it's this, you change the x value into 1 and find out what the y is. Right? That's why it's just reflected in the y-axis.
Okay.
Right? Because when x is negative, it turns into positive. So for example, if I have a function f of x, let's say it has this this shape here. Right? If I suddenly turn that into f of absolute value of x, it just means that whenever at the point where it's 0, I would take that section there and I reflect that around the y-axis, and I ignore this section over here. Does that make sense?
Yeah.
It would just be symmetrical, right? Because when x is negative, it turns into positive, and you evaluate and you get the same y value.
Okay.
Okay?
Yeah.
Alright, so that's the idea behind this function here. It will flip around. Okay. And then this example is a little bit more involved. We're slowly getting to the more specialist mathematics part of it. So when you derive ln of so question A, right? When you derive ln absolute value of x, okay? ln of absolute value of x. So remember, normally you would get 1 over x.
Yeah.
Right? So normally you get 1 over x, but if, so this is if x is more than 0.
Yeah.
Yeah? But if x is less than 0, it will, actually, x is not, let's see, y equals ln negative x gives, so it will give you the same thing. So if this is more than 0, it will be obvious, but if x is less than 0, because when x is more or less than 0, it changes. So when x is less than 0, then technically ln of absolute value x would be ln of negative x. Because x is less than 0.
Well, like, can't you have that?
Hmm?
Isn't that like impossible?
Wait, I'm saying x is less than 0. Example, x would be negative 2. See if it fits. If you put negative 2 in here, that would be ln of negative 2, which is ln 2.
Oh, okay.
Does that make sense?
That magnitude thing or whatever. Does it cancel it so it's positive?
Yes, because x is, you can have negative in here, but the x must be negative if it's negative. So that you have negative, which is a positive.
Yeah.
Yeah? Okay? So many things can go inside ln as long as the result will be positive. And that would be the restriction. You just can't have 0.
Yeah.
Right? You can't have ln 0. So that's why if x is less than 0, then ln x would just be ln of negative x. So when you derive ln of negative x, that would be chain rule, right? 1 over negative x. And then times that by derive negative x, yeah, it would be negative 1. And that also turns into 1 over x. And because of that, right? So if x is more than 0, then ln absolute value x is the same as ln x, which means the derivative would be straightforward 1 over x. And because in both scenario, when x is more and less than 0, in both scenario, the answer are always 1 over x, right? Then we can make the conclusion that when you derive ln of absolute value of x, the answer is simply 1 over x.
Alright, that makes sense.
That makes sense? Yeah? Because in both negative and positive case, the answer is both 1 over x. So it sort of aligns, there's one universal result. But the restriction is x cannot be 0. Because you can't ln 0.
Yeah.
And also you cannot divide by 0.
Yeah.
Right? Okay, second example. This one is a bit tricky. Find d over dx of ln sec x. Okay. D over, so derive ln of absolute value of sec x. Okay. All right. Let me quickly check what's the textbook's explanation. Yeah. So okay. Negative. Yeah. Okay. All right. Yeah. So when you see this one, it's a function in a function, so you need the chain rule.
Okay.
Okay. So okay. So the first part is actually to turn that into 1 over cos. Remember, sec is 1 over cos.
Yeah.
Right? So then that would be ln of cos x everything, because 1 divided by means is power minus 1.
Yeah.
Right? And the power doesn't get affected by absolute, because if it's negative, it still stays negative. It doesn't matter. 1 divided by a negative is a negative. 1 divided by positive is a positive. But we can bring power to the front rule.
Yeah.
Yeah. So that'll be negative ln of cos x.
Yeah.
Okay? Yeah? Now, given this one, then so now you need to use the chain rule. Let u equals to cos x. Yeah? And so you would have du over dx would be negative sin x.
Yeah.
Right? And then y would be, so let y equals this. Right? So then y would be negative ln absolute value of u. And remember, we just proved that when you derive this, you would get what? So dy over du would be simply negative 1 over u. Because we're differentiating with respect to u. Remember, chain rule means you derive what's inside. But this one is a bit trickier to go through. So the specialist chain rules are normally a bit harder to go through. So I'd recommend to use the u and y and du over x, dy over dx thing. Okay? Make sense so far?
Yeah.
Yeah, so the result that to get this straight to that is based off what we did earlier, right? It's the result that we found earlier here. Okay, so yeah, so that's why you get that line, and then dy over dx would be what?
dy over dx.
Would be these two
Yeah, there's two.
multiplied,
Yeah.
right? Yeah, so that'll be and normally in chain rule, I would want to get rid of the u first. So I know u is cos x, so that would be negative 1 over cos x.
Oh, okay. So, yeah.
right? So actually you get these two and multiply them. So that would be negative 1 over cos x times sine x
Which is then just sine of cos.
times, sorry, negative sine x would be, yeah, sine x over cos x, which is
10.
10, which is 10x.
Yeah, cool.
Okay, so yeah, so that's how you would get chain rule. See, 10x, that's how you get chain rule in order to solve these ones.
Okay.
Okay, so the textbook they write in a very, very short way, but basically the formula is this thing here.
Yeah.
Right, just multiply dy by du times du by dx. The way to remember it is the du top, the u bottom will kind of cancel out. You don't. That's what you think to remember, but that's not how it works. Okay, calculus doesn't work actually that way. So it's not a fraction, but it's just saying that when you derive this times derive that, yeah, that's the answer dy by dx. Right, because the du top and bottom sort of cancel out, so the answer will be dy by dx. Okay, next. So yes, so the result that we, from example 3a, that actually proves the result over here. Okay, when you derive ln of absolute value x, it will just be 1 over x. And x just can't be 0. So there's no longer a restriction that x must be positive, because absolute value turns any negative into positive. Okay, alright. Next would be, yep, so this one is just, this one is just antiderivative, it's just a normal rule. Okay, when you antiderive 1 over a linear function of x, see this one here, 1 over a linear function, it's just, it should become ln of whatever that is, but note that it's absolute value.
Okay.
So remember in methods, if you do that, something like that, then you would be equals to 1 over a, right, divided by coefficient of x, and then ln of normal brackets. But the restriction is ax plus b must be more than 0.
Yeah.
Right? In specialist, now that you have learned the special notation, absolute value, you chuck the absolute value is 2 straight lines. So I draw a straight line. It's 2 straight lines here. And so this one doesn't need to be more than 0. It just cannot be 0. But it can be less than 0 now.
Yeah.
Yeah? Okay? So yeah, so that's a new stuff. It will be the absolute value. And then the restriction is it just cannot be equals to 0. Okay. Next, this one. Yeah, this is slowly getting to the fun bit. Yeah, slowly getting to the fun bit. This is 11a, it's still easy. 11b and c is the mind-boggling one. That's why I'm just going through all the content. I have to record the lesson because you most likely have to watch it at some point when you're doing these exercises or redo the examples.
Yeah.
But anyway, so find an antiderivative of this thing. So that is saying if you go let fx is equals to 1 over 4x plus 2, and x is not equals to negative 1 over 2. Do you know how they get this thing?
What do you mean?
How did they get this restriction? You know? Hint, has something to do with the denominator.
Maybe that will equal 0.
Yes, the restriction is this plus 2 cannot be equals to 0.
Yeah.
Right? And you move the 2 over, 4x cannot be equals to negative 2 divided by 4. 4x cannot be equals to negative 1/2.
Oh, yeah.
Okay, so the restriction for this one is mostly because of the divide by 0. Cannot divide by 0. Okay, most of them is like that, right? The other one will be cannot take ln of 0 or negative numbers in methods.
Yeah.
Anyway, so yeah, so fx equals to that, which means an antiderivative, big F of x, right? When you antiderive that, it would be ln of whatever that is, but we've learned absolute value, so it would be this absolute value here. Okay, see, it's a bit different. Okay, if you start doing it a lot, you see that there's actually a difference between this one and methods.
Yeah.
Okay, so yeah, so that'll be 1 over 4 ln of 4 equals 2. Okay, make sense?
Yeah.
Right. Now, question B. You see the difference in question C. Yeah, skip question B. You see the difference in question C. Antiderive -2, -1 of this thing. dx. Remember, it just cannot be negative 1 over 2, but it can be a negative number. Normally, you won't be able to get a negative number, right? But this time, you can. Why? Because when you apply the formula, so this would be big F of minus 1, and then subtract big F minus 2, right?
Yeah.
Big F minus 1 means you take minus 1, you put into the x here, right? So, because this is an antiderivative already. Alright, so that would be 1/4 ln of 4 times minus 1 plus 2.
Yeah.
You see where we're going? Minus 1/4 times, and at this point you should recognize that, hang on, they're both multiplied by 1/4, so if you put the brackets outside of it, take out 1/4 as a common factor, yeah, then it would just be ln, right? And of 4 times negative 2 plus 2. You see why we need the absolute value now?
Yeah.
That would be 1/4 ln of
2. Negative 2.
negative 2. Absolute of that is 2. But technically it's absolute value negative 2, right?
Yeah.
And then minus, so still got the brackets there, ln of negative 6,
Yeah.
right? Yeah, and that would actually be 1/4 of ln 2 minus ln 6, because absolute value will turn into positive, and now we can have ln of a negative number as long as it's wrapped around absolute value,
Yeah.
right? So then that would be 1/4 ln 2 divided by 6, which is 1/3.
Yeah.
And if you want to be fancier, you can go ln of 3 power minus 1, which is negative 1/4 ln 3. Okay, so that's the, I think they would go, yeah, negative 1/4 ln 3. Okay, make sense?
Yeah.
That's it. That's all the examples for 11A.
Alright.
Okay, so the only new thing is the absolute value. I've prepared like, basically you need to go through the first 5 questions in 11A, which is all of them.
Oh.
But I did not pick all of the questions for question 5 and question 3 and question 2 either. And not even question 1. I only picked the ones that it's good to get started with. The ones that I didn't pick are a little bit harder. It takes more effort, but I think later, do them later. Okay, when I cycle back, I will assign you those harder ones later as a revision. But for now, just do whatever is in this set.
Yeah.
You finish this, good enough.
Yeah.
Okay? Yeah, that'll be good enough. Okay, moving on, 11B.
Inverse trig.
Inverse trig function.
Oh,
Ready for this?
Yeah.
This is the sweaty stuff. It starts to get sweaty around here. So yeah, only 11A is like kind of familiar. 11B is completely different.
Yeah, what? Inverse trig.
Okay? Inverse trig function. There are only 3 inverse trigs: sine -1, cos -1, and tan -1. Okay? And then you put the x in, of course.
Yeah.
Okay? Now, the formula is this. When you antiderive each of these, actually I'll use the fx notation. So if this is fx, then an antiderivative of that, big F of x, would be, wait for it, sine x is 1 over square root of 1 minus x squared.
Okay.
You just have to remember that.
Yeah.
Okay? If you do it enough, yeah, the proof is in the textbook, you can read it.
Nah.
It's interesting. It's good to read. I'm not going to go through that because the textbook explains it quite well.
Okay.
Okay, but I'll focus on how to apply it to do the questions.
Yeah.
So, and then cos x would be -1. It's the same as this, but negative at the front. So -1 over square root of 1 minus x squared.
Okay, at least it's all the same.
It's similar. The only thing that's different is tan. Inverse tangent is 1 over 1 plus x squared.
Okay.
No square root.
1x squared. Okay, yeah, cool.
Okay?
Yeah.
Yeah? So this is the very basic rule. But what you actually, so that's a basic rule. So this is only to introduce you to the main formula, alright? But the one you actually have to remember is this one. Actually, yeah, remembering this one is not bad, right? That's you would need to remember this, and also a slightly altered version. Okay, actually maybe we'll put them side by side so you can see the difference. Okay, the slightly altered version is this. So same thing, fx and then an antiderivative. So this would be sine, inverse sine of x divided by a.
Yeah.
Okay? And so this will be inverse cos of x divided by a.
Yeah.
And similarly, this would be inverse tangent of x divided by a. Okay? The reason why you need to learn this is because the formula is quite convenient. Sometimes, if you apply this, you get to the answer a lot faster. Alright? So yeah, the answer would be just a little bit different. So when you enter the right, when you divide it by a, that would be a. So the difference is a over square root of a squared minus x squared.
Oh, okay.
So see, the trick is, think of this one as x over 1. And that's why this is like 1 over 1 squared.
Yeah.
Right? So the base formula still stands. It's just that a is 1. So x divided by 1, so that'll be 1 over 1 squared minus x squared. And so the cos version is basically the same. You just get minus a over square root of a a squared and then minus x squared.
Oh, yeah.
Okay? Tangent, same thing. So that would be over and then plus x squared, but instead of 1, you would get a over a squared plus x squared.
Okay.
Okay?
Yeah.
Yep. Alright, let's see if we can get straight to the example. So ignore the proof, ignore that proof as well. Yeah, so, oh sorry, wrong formula. This one is just 1, my bad. This one is always just 1, that will be minus 1. The only one that has a is the tangent one.
Yeah.
Yeah, so the only one that has a on top is the tangent. Okay, but all the other ones will have the 1 turned into the a squared.
Yeah.
Well?
Yeah.
Okay, yeah, I'll keep it this version here. Alright, so let's go to okay, the next bit is this thing here.
Negative a to a.
Yes, why is it negative a to a? And why is this one, what was it? Yeah, why is the restriction for sine and cos from negative 1 to 1? Why is that the case? What do you think?
1. Oh, because if you go anything higher than 1, then it becomes a negative number.
What becomes a negative number? You're on the right track. Which one?
The denominator, the bottom one.
Yes, that's right. Look at the bottom here. This is strictly must be more than 0.
Yeah.
Right? When you move the x over, 1 must be strictly more than x squared. Right? And remember, when you have x squared as a graph, it looks like something like that, right? X squared, right? And if the answer must be strictly greater than 1, let's say this is 1, right? Then that means there are 2 regions. Okay? So x squared, right? So to get 1, you get, x is 1 or negative 1, right? So the first region is this one here, right? This part is more than 1. This part is also more than, 1 is less than, my bad. So it actually is this section here. Right? That's a section that we are interested in. It must be within this little box here. It cannot be that section.
Yeah.
Right? And that's why negative 1 is less than x, less than 1.
Okay.
Make sense?
Yeah.
Yeah? Similarly, if you look at this one here, because the answer has a squared less than a squared minus x squared, and the restriction is a squared minus x squared must be greater than 0. Right? So then a squared must be greater than x squared, and then that's the same thing, right? When you square root of a squared, you get a. So then it's the same graph where so x squared must be strictly, I rearrange it, x squared must be less than a squared, right? So if here is a squared, then on the x-axis it would be a here, and that would be minus a.
Yeah.
Right? And it must be strictly less than that. So we're talking about just this region here. You cannot have that. You only care about this section here.
Yeah.
Right? And it cannot be equal to y. It's strictly less than, yeah? Because, this one is strictly more than 0. Why can't this be equal to 0?
Because you can't have something over 0.
Yeah.
1 over 0.
Can't divide by 0. See what I said earlier? It mostly relates to all these restrictions.
Yeah.
All these mathematical restrictions. Don't think about it. The proof for this one is like it's the job for mathematicians. Okay, just trust that you can divide by 0 and you can't square root a negative number for these kind of graphs. The technically complex number you can deal with complex numbers, but for these ones, just say no because they are trigonometry related things. Okay, all right. So yeah, so that explains the x less than negative a to a, and that's why for tangent there's no restriction. Okay. Why? Because as long as a is not 0, if it's 0 divided by anything is 0, right? So a is already not 0. You can't have a equals to 0 here. You can't have x over 0. So if a is not 0, this thing can never be 0.
Yeah.
Right? Even if x is 0, it will just be a squared plus 0, which is still some sort of value, a squared.
Yeah.
Okay? That's why for tangent, there's no restriction.
Okay.
X is any real number.
Yeah.
Alright? Yep, same here. 10 power minus 1. Yeah, so inverse tangent of this, yeah, it's also no restriction.
Okay.
Okay?
Yeah.
So note that you may need to watch this again later to get it when you attempt the examples. That's okay. This concept would require like 1 or 2 times passing over, and you might need to learn it from different content. You might even need to go and watch another YouTube video, find a different explanation. Okay? But anyway, let's try out the actual examples here. Alright. Okay, differentiate. So question A. D over dx of sine minus 1 x on 3. Do you remember the formula? What's the formula?
From this one. Sine is, it's 1. This is, 1 over square root 1 minus x squared.
Yes, but this one is x over a.
What do you mean?
Alright, this is x over 3.
Wait, so it's a squared, no, a.
Yeah, a squared minus
x squared.
X squared. Yes, what's a?
A is 3.
Yeah, so it's 3. Yeah, that's it.
Oh, okay.
Okay, so now it'll be 1 over square root 9 minus x squared. Done.
Is that it?
Yeah.
Okay, so you have to solve for x or whatever.
No, you only ask to differentiate.
Differentiate, okay.
Okay? Question B. Differentiate cos minus 1 of 4x.
This is equal to 1 over, negative 1 over, what's it, 1 minus x squared?
Yeah, but again, this is not just x.
Wait. So now do fill the...
Chain rule.
Wait, what do you mean this is not just x? That is x.
This is a function of x, it's not just x.
Can't you just times it by 4 at the end?
Yeah, okay, yes, that's not wrong. Okay, let's see what you do. That's not wrong, so that would be negative 1 over square root of
4?
No.
X.
If you're thinking of this whole thing as that whole thing, that would be 1 minus.
Yeah, 1 minus x squared.
Not 4x, everything squared.
Oh, yeah. And then
Okay, pause. Think of this as function in the function. So you let u equals to 4x, right? So then u dash would be 4, right?
Yeah.
Yeah, and then let's say y would be equals to inverse cos of u, right? So then y dash would be minus 1 over square root 1 minus u squared. You see where I'm coming from now? U squared, and u is 4x. That's why it's 4x everything squared. Okay? And then yes, you do times that by 4.
Alright. So it's just simplify, right?
Yeah, so that'll be minus 4 over square root of 1 minus 16x squared.
And that's it.
Yeah.
Okay.
So most of these ones you will need to use chain rule. See, when you see something like that, just chain rule it. Don't bother, right? Just chain rule it. So question C. Inverse tan of 2x on 3. For these questions, once again, I would normally use the full chain rule, okay? Because sometimes it's a bit hard to see the final answer. So u is that, so du over dx or u dash would be 2 on 3, okay? And so y would be equals to inverse tangent of just u, right? So then y dash would be, what would that be? Remember the formula?
Is this the a one or not?
There's no a because that's just one u.
Okay. So
Remember, so that the idea is you let the whole function be u, so you don't need to worry about deriving that function yet.
okay.
You just deal with, it's like 10 minus 1x, right? 10, this is just 10 minus 1, 10 inverse 10 of u.
Okay.
Okay, so what would that be?
It's 1 over 1 plus.
Remember, you're differentiating with respect to u. Okay.
2
Now, make sure you write this. dy over du, yeah?
Oh, 2x on 3 times by 2 on 3.
No.
No, but like 2
Use the formula first, it will be u squared.
squared. What do you mean squared?
Yeah, the formula has always, 1 plus x squared. Yeah, they always have x squared. Always.
Yeah.
Okay? So it will be 1 plus u squared, right? Right?
Yeah.
And what's the u squared?
4x on 6.
Yeah. That will be 4x squared on 6. But you see, people don't like fraction in a fraction. So they would simplify it by, and now this is something that this is probably a new skill. Add these two, that would be 6 plus 4x squared, bring the 6 on top. Does it make sense? No? Okay.
So yeah.
It will be like this, right?
Times it by.
And then that would be 1, right? The top, and then divide by the bottom. So 1 times by the reciprocal of the bottom.
Yeah.
So you see how the top of the bottom, aka the 6 plus 4x squared, is still at the bottom, but because divide by 6, it gets flipped over,
Yeah. Makes sense.
right, to the top. So that's why it turns into 6 over 6 plus 4x squared, right? So that's dy over du, and this is du over dx. So yeah, I guess it's best to write du over dx. So then dy over dx would be these two times together. Okay, so 6 times 2 is 12 on 3 is 4. So that's 4 over 6 plus 4x squared.
Yeah.
Well, let's just simplify.
Yeah. Yeah.
Make sense?
Yeah.
Yeah, when you try it out, you might need to actually write the step and do the simplification. But yeah, you can quickly do that as well. Okay, next one would be d, inverse sine of x squared minus 1. Inverse sine of x squared minus 1, same thing, u equals to x squared minus 1, du over dx would be 2x. And then y would be inverse sine of u. So then dy over du, with respect to u, yeah, would be what?
1 over. What is it? Is it x squared? 1 plus x squared, right? But it's 1 plus u squared.
No, that's tangent.
Square root 1 plus.
No.
Minus 1 minus u squared.
Yeah. Okay, now get ready for the expansion. So this one would be 1 over square root of 1 minus x squared minus 1, everything squared. Aha. In this case, you would consider expanding the brackets, okay, to simplify it. So you would expand the brackets. Why? Because when you expand it, remember what's the formula for a plus a minus b everything squared? See, I told you it comes back again and again. What's the formula for this thing?
A squared minus b squared.
Nope.
Because minus 2ab plus b squared.
Yes, you cannot get this wrong like at all.
I need to practice more. No.
Yeah, so this sheet. So then that would be 1 over, right? Pay attention closely. 1 minus, and because it's a minus, I always write the rest in brackets. It's too risky to do 2 steps at once. Just do the expansion first. That would be x power 4 minus 2x squared plus 1. Any question?
No.
No? Okay? And then you would expand the brackets. That would be 1 over 1, so square root of 1 minus this whole thing. So that'll be 1 minus x power 4 plus 2x squared minus 1. Alright, see 1 minus 1 cancel out.
Yeah.
Alright? So that'll be 1 over square root of 2x squared minus x power 4.
Yeah.
Okay? I just write the 2x squared first so I don't write minus and plus. And then you take out, because you see common factor x squared, right?
Yeah.
Then you would take out x squared. Like so. Next bit is crucial. This thing What is this? What does that thing turn into?
X power half?
No. Absolute value of x.
Yeah.
Okay? Okay, alright. Here's a little snippet.
Where's it good at?
This is a formula. Square root of x squared is actually the absolute value of x. Why? Because when you square a number, that number can actually be negative now. Because remember how when you have negative, you can't have negative 4, you can't have that normally. Yeah? But what if you have negative of negative 2 everything squared? The answer is 2.
Yeah.
Right? Because when you square negative 2, that would be just 4 and that would just be 2.
Yeah.
But you see, this if you just write, oh yeah, negative x squared equals x, that would be wrong because x is negative 2, but then you're saying the answer is 2, it's not negative 2. So technically, it's the absolute value of negative 2.
Okay.
Because you're squaring it, you're making a negative into positive, right? So the answer has to reflect the fact that if it was negative, it got turned into positive. And that's why it must be absolute value of negative 2, which is then the correct answer here.
Okay.
Make sense?
Yeah.
Yeah? So you have to deal with negative numbers in square root. That's why it's absolute value.
Okay.
Okay? So yeah. So, okay, given this situation, right, that means that dy over dx would be 1 over this thing has a strange absolute value of x times by square root of 2 minus x squared. This is sweaty. I'm recording this and you better go back and watch it. Times 2x.
Yeah.
Okay? And remember, there are two scenarios when you have absolute value. When x is less than 0 versus when x is more than 0. Why can't it be equals to 0?
Just can't divide by 0.
Can't divide by 0, very good. If this is 0 times that whole thing would be 0, right? So you can't divide by 0. So yeah, so when x is less than 0, then dy over dx would be 1 over negative x. Does that make sense?
Yeah.
Does that make sense?
Yeah.
Yeah, because when you have a negative number, the absolute value of that is the opposite of the absolute of the negative number.
Yeah.
Yeah, like if x is negative 1, you would get absolute value negative 1, which is negative of negative 1, which is 1.
Yeah.
Right? So that's why absolute value of a negative number would be negative of that, whatever that is in there.
Yeah.
Yeah? So yes, and that's why this one turned the negative x at the bottom and the x on top will cancel out, but the answer will be negative 2 over square root of 2 minus x squared.
Okay.
And when x is more than 0, well then that's simple, it's just the same thing. Right? Instead of flipping it around, it's just going to be the same. So that'll just be 2x over just the simple x and then square root of 2 minus x squared. The 2x cancel out, so it'll just be positive 2 over 2 minus x squared.
Okay.
So there are two answers depending on whether x is less than or more than 0.
Yeah.
Okay? Bit trippy, right?
Yeah.
Yeah. So that's actually arguably is the hardest example. I mean, that's the longest one in this one here. Okay, so that's why they give you two scenarios. Yeah. And oh yeah, and actually you should have put in. Oh yeah. So x is less than 0 and more than 0. But remember, so when you derive this, right, the restriction must be negative root 2 less than x less than root 2. Remember, because of this thing there?
Yeah.
Yeah? And it's negative root 2 is root 2 because it's like root 2 squared.
Yeah.
Right? Remember how if we got like the one up here. So now I'm going to add the restrictions in. So this one would have the restriction x. Do I have space? We have space for these. Okay, so I'll add the restriction, let's say for this one here. So this one would be negative a less than x less than a. Same with this one. Right? So this one would be negative 1 less than x less than 1. And then this one will also be the same. Negative 1 less than x less than 1. Okay, make sense?
Yeah.
And because, remember when you're solving it, the a squared here would be the y value, and it's x squared, so the x value would just be a. That's why it's simply just a.
Okay.
So that's why when we have a value like 2, right, 2 minus x squared, you have to square root that to get the domain, which is from negative root 2 to positive root 2.
Yeah.
Okay?
Yeah.
So, so now that we know that, then the final answer, right? The final answer, so d over dx would be equals to the negative version, right? That, and that's for 0, negative square root 2 less than x less than 0, when x is negative,
Yeah.
right? But it can't go past negative root 2, yeah? And then that would be equals to, the positive version would be square root of, it would be the positive version when 0 less than x less than positive root 2. So it's kind of like saying from 0 to negative root 2, this is the domain that will give this derivative. Alright, and then the other domain from 0 to root 2 exclusive would give this derivative.
Yeah.
Make sense?
Yeah.
Okay. At least that makes sense.
Yeah.
When you do it again at home, you gotta go through it. And you know what, if you need to, read the textbook, watch online YouTube videos, whatever it takes to understand these concepts.
Okay.
And I think that's the only example. Yeah.
Okay.
That's the only example for 11b. But the questions in 11b has complex familiar, which is not assigned for you this time.
Okay.
You can attempt it because it's a holiday. You should try to study a bit more if you can. So attempt these ones. And if you can even read forward, right? We're going to just go through basically everything in chapter 11. Okay. If you can understand the majority of the content, just let me know which chapter you're up to, and I'll just quickly go through those on next lesson, and not having to go through like everything. Okay. But I think it will take you some time just to focus on these ones. Maybe you can try the complex familiar. So reinforce these chapters from now till next week.
Okay.
Okay? Rather than trying to go on first. Just reinforce these ones. Because I think when they start at school, the first week will be focused on most likely all of they will do 1 chapter per lesson, right?
Yeah.
11A per lesson, and then 3 chapters per week, right? 3 or 4 chapters per week.
Yeah. Well, yeah. Maybe 2 a lesson if we're fast, but yeah.
Okay. If it's an easy one, but I don't think these will be easy.
No, within 1 lesson a week probably. So we've got
Yeah.
10.5, so yeah.
Yeah. So the first week, I think it will be a bit hectic for everyone trying to revise or whatever. Go through like exam results and whatnot. I don't know. But yeah. So hopefully, 11 ABC will be for your first week at school. Hopefully. So next week will be like DEF or something, or maybe DEFG if the content is easy enough. But we'll see. I haven't seen through those chapters yet. Not the exercises yet. Okay. All right. Make sense so far?
So far.
So far, so good. So that's 11B.
Yeah.
Okay. 11C is antiderivatives involving inverse trigonometric functions. It's just the other way around, yeah. Okay?
That's not too bad.
It's not too bad. It's not too bad.
Extension from methods, really.
It is extension from methods, yes. That's why to do specialists, you have to do methods.
Yeah.
Yeah.
Which makes sense.
Okay. Right. Okay, so that was that chapter. Now is 11C, antideriving. It's just going to the opposite direction. So I'm just going to copy and paste this one here. It's just going to be the same thing. Alright, and I have explained everything already. The thing about the restriction for this, x from negative a to a.
Yeah.
Yeah? And because of that thing at the bottom, that can't be less than 0. Must be more than 0.
What are the formulas? Oh, it's just the same, x over a. Oh, okay. Alright, cool, yeah. Oh, okay.
Yeah, we learned the forward, now we have to do the backward direction.
Yeah. Okay, that's not too bad.
Examples. The algebra, the fraction algebra is what's tricky in these initial questions, but concept is similar to the last one. If you got the last one, then this one won't be too difficult. So find an antiderivative of, whoops, no, I don't want the solution. Okay, so find an antiderivative. Question A, asking to find an antiderivative, so we don't even need to antiderive it. Just say let fx be whatever that is. Right, so then big F of x would be If you want to, you can convert that to the squared version. So it's a bit easier to see. Okay? So then big F of x would be, that is 1 over square root, so that will be sine, inverse sine, right, of, and there is an a value, so that would just be x over 3. But the important thing is you need to write plus, no, it's an antiderivative.
Oh, so it's any no.
So we're saying c is 0.
Yeah.
For this is the important thing. For x between what values?
-3 to 3.
Exclusive.
Yeah.
Yeah.
Alright, cool.
Okay, not too bad.
Yeah, that's not too bad.
Question B. Let fx yada yada. You know, work this one out. Then big F of x would be
Sine again.
sine of
Inverse sine.
inverse sine of.
Oh, why is there a 4 there now?
Yeah. So what do you do?
Whoa. It's
Alright, let's take this.
Wait, 1 over 4. Wait, 1 over 4 sine.
No.
Ah, shit. No, is
Okay.
that 1 over 4 in front of sine?
No.
Uh,
Okay. As I said, the fraction algebra is what will get most people in this chapter. You do want to get rid of this. But how?
I don't know, it's trapped.
You get rid of it by take out common factor. Well, it's not common factor, but you take it out as a factor. If you take it out as a factor, it will be root 4 times what? What's left behind? Of course, this is going to be x squared, but what's left behind here?
You can't do that because there's a 9 there.
You can. If you take out 4, it's just 9. What?
9 over 4? Oh, okay, because how many times when it cancels out?
Mhm.
Wait, oh yeah.
Mm-hmm.
Because the square. Wait, no, doesn't that go to 16 or 9 when you times it in?
No, it will be 4 times 9 on 4. The 4 cancels out. So if you take out 4 from a factor, you basically divide that number by 4.
Yeah, okay.
Right?
Yeah.
So yeah, moving on. That would get me, so root 4 is just 2, right? Okay? 9 on 4 minus x squared.
Yeah.
Okay? And that would be 1 over 2 times 1 over square root 9 on 4 minus x squared. Can we antiderive it now? What's an antiderivative?
Yeah, we can, right?
Yeah, we can, yes.
So you just take the half out, so half.
Yep, half good.
Bracket.
You don't need
inverse
brackets.
Or sine.
It's just sine.
inverse sine. 4x on 9.
No. So close. What's the formula?
X on A, right?
Yeah. If you got
Yeah, so it's 4 on 9. It's
no,
not 4x
in-
on 9.
inverse sine of x on a, when you derive this, what do you get? Read the formula again. That would be what? 1 over
X
the basic
on A.
formula.
X on A?
No.
Wait,
When you
what?
derive it, when you derive this equation, it's 1 over square root.
Oh, 1 minus 1.
No. If it's x on a, it's
A squared minus X squared.
a squared minus x squared. Why do I highlight a squared?
Wait, so that's when you derive it. Wait, I'm
Yeah, so we're going backward now, right? We're going from here to here.
Oh, so 3 on 2, so then it's 2 on 3, 2x on 3, right?
Yes, it's 2 on 3 times x, yeah.
Okay. Oh,
Okay.
it's squared, so you go to the square root.
Yes, because this is technically 3 on 2 everything squared, right? Because then would be x over 3 on 2, which is 2x on 3.
Yeah. I get the flipping step, it's just...
Yeah,
remember
it's the squared one that you missed.
Yeah.
Okay, that's what I'm saying, the squared one,
Yeah.
a squared. Okay? Alright, example C. Okay, this one when I was trying it by myself, I made a mistake. See if you do. Okay?
Probably will.
Let
Fine.
fx equals to 1 over 9 plus 4x squared.
Oh, so is this the tan one?
The tan one, yes. What's the formula for tan? Okay, to help you a little bit, I would write the formula for tan here, right?
I don't, is it 1 over
No, it's wrong already. When you derive inverse tan of x on a, what's the answer?
I can't remember.
It starts with
Oh, A. This
A.
was only one A on the top, and then A squared plus x squared.
yeah, okay, right. I'll leave this one here. Now, how do we change this so we can antiderive it?
You need to make the derivative of the top, like the derivative of the bottom.
No,
the
you
top.
just need the numbers. Just move numbers around. That's a hint for you.
What?
You just need to move numbers around.
Oh, take. You want to isolate 4 or the x squared.
You do take 4 out, yes, and that would be 9 on 4, right? 9 over 4 plus x squared. Yes, what's the next step?
We want A equals 2 values. I don't know. Oh, now do you just do the thing?
No,
Okay.
not yet. Remember, this is 1. You want A. What's A?
A is 1 right now.
No. A is whatever.
9 on 4.
No, it's 3 on 2. A squared equals 9 on 4.
Yeah.
That's why A equals 3 on 2. Which means you will also
Yes.
need the A on top.
Yeah. Oh, so you need to get that on top.
Yeah, how?
I don't know.
Let's say we take out 1 on 4 first, right? So then what's left in here is 1 over 9 over, or let's try as 3 on 2 squared plus x squared. You want 3 on 2 on top, but you can't just get 3 on 2 on top and do nothing about it. What do you have to do to cancel it out? You have to time it by the opposite.
Oh, yeah. Yeah, okay.
Make sense?
Yeah.
Yeah?
So that just cancels it.
Yeah, right? So then that would be 2, 4 cancel out, right? So that would just be 1 on 6 and times it by 3 on 2 over 3 on 2 squared plus x squared. Now that's in the form of a over a squared plus x squared. So then an antiderivative would be, now you've got a constant factor, it's just that. Of what?
3 on 2. 3 on 2.
Try again.
3 on 2x.
No.
Oh, wait, x. Oh, wait, oh, yeah. 2x on 3.
Yeah, 2x on 3.
Yeah.
Yeah.
Yeah, okay.
Okay? A little bit trippy, right?
Yeah, it is.
Yeah. That's why I said the fraction algebra is the trippy part.
But I get it. I actually get that.
Yeah. Just need practice.
Yeah.
Okay, only two examples. The next one is the definite integral. And that's it. After the definite integral, you're basically set for. You just need a lot of practice. Like the fractions algebra will trip you up quite a bit, and also the definite integral will trip you up a little bit. I'll show you what I mean. Okay, evaluate following definite integrals. Question A. Okay, be prepared for some tricky trigonometry stuff. That's why if you get good with, especially it really helps you get better at methods. Because it tests stuff that in method you see a few questions. In specialist it's like the foundation. So you do like hundreds of those questions. Even though in method you might only see them once or twice. Okay? So yeah, so this one, anti-deriving it, what would that be?
What is this? This would be sine. So sine power -1. And then we're already given the A, right? We don't have to change anything. So that's x on 4.
No.
Oh, x on 2.
Yes, x on 2. 0, 1. Okay, let's sub it in.
But it's sine -1.
Okay, wait. Minus sine of 0. What is inverse sine of 1/2? Okay, remember, what's the restriction? The restriction is x what?
It can't be 0. That's the only restriction.
No. Remember, it's related to that.
Oh, -4 to 4.
No.
What? Negative 2 to 2.
Yes, -2 to 2. Just remember, the a value is the square root of that.
Yeah.
Okay, so x between -2 and 2. What's x? So when you think about it, what's the meaning of x if you have inverse sine of that?
I don't know.
Okay, well, the value is that, but okay, what's inverse sine of 1 on 2?
I don't know.
What's the answer of inverse sine of 1 on 2?
I have no clue. Inverse sine 1 on 2. What do you
Okay, think. Let's inverse sine of 1 on 2 equals to some value a, right? Or value m, for example. Okay? What's the opposite of that?
What do you mean the opposite? Like sine?
What's the opposite? Sine m equals 1/2. Make sense? That's what inverse sine is, right? You get sine of something equals 1/2, and so you inverse sine of whatever that is, and you get the value inside. Now remember, what's the meaning of m here?
30? Is it 30?
Yes, m is an angle. What I'm saying is that m is an angle, right? Therefore, m is an angle. Does that make sense? Yeah. Okay. So basically they're saying, okay, what angle gives you sine equals 1/2?
30 degrees.
30. So it would be pi on 3. Remember, when you're dealing with sine and there's no degree, there's no nothing, it's assumed to be a radians.
Pi on 3. Where'd you get that from? When was pi 30?
30 is pi on 6. Yeah, pi on 6, not pi on 3.
Oh yeah.
Pi is 180.
Triangles,
Yeah. Okay. And then minus what angle gives you sine 0?
What angle gives you sine 0? 0?
Yeah, 0. Yes.
Oh yeah, because it's 0, yeah.
Yeah, inverse sine of 0. So okay, so the logic is a bit strange on this one here. This one looks something like this. So what you're saying is, instead of having the angle and find the sine, you're saying that, okay, this is a sine axis. Which angle gives you sine equals to 0, right? And those angles are this or that, right? But in this one, just remember the angle is normally like positive, negative. So we'll take the value 0 here, right? The angle 0, the easiest one.
Yeah.
Okay. So inverse sine of 0 would just be 0. I think they mentioned in the textbook that it will be between negative pi on 2 and pi on 2.
Okay.
Yeah, it's in the proof of the formula. So yeah, so that'll be pi on 6 minus 0, which is just pi on 6. The answer for A.
Okay.
Okay, B. Alright, next definite integral. Okay, yeah, so next definite integral is B. So when you enter derive, whatever that is, save a bit of time, would be equals to what?
This one's tan, right? Inverse tan of x on 2.
Inverse tan
Of x on 2.
over x on 2. That's it?
Sure.
No.
I don't know.
You didn't see it, did you? Why is it wrong? Why do you think that's wrong? If I were to write it properly,
Oh, because you got to do the derivative thing on top, right? Because it's A. Because it's A on.
it's A on top.
Oh man.
Is A on top? This is 1. A is what?
2.
2. So if you want 2 on top, what do?
You times by 1 on 2.
Yeah, you times by 1 and 2 at the front.
Ah, okay.
This is the advanced part in methods. Remember the one way apply. Yeah. So the methods one, you have to derive the bottom and then see what's on top, and then you have to times it in. But this one is just basically, remember, A is on top, and you want A on top, and it's just 1, so you want 2. You just times it by 1 over 2 to balance it out.
Yeah.
Okay. So yeah, so that would be 1/2 inverse tangent of. Now then, you can go x on 2.
Yeah. Cool. And then from 0 to 1, right?
Yes. And remember 0 to 2.
Yeah.
Okay. So that will be 1/2 of inverse tangent. Remember, I just took out the 1/2 as a a constant factor, yeah? So that will be inverse tangent of 1 minus inverse tangent of 0.
Yeah.
Okay, what's inverse tan of 1? What angle give you tan equals 1?
I can't remember.
It's the 2 triangles. Imagine in your head.
It's the 45 one, so the pi on 4 one.
Pi on 4, yes.
This is
So
pi.
inverse tan of that would be pi on 4 because tan pi on 4 is 1.
Yeah. Yeah, yeah.
Yeah? And what angle gives you tan equals to 0?
None of them. None of them do. None of the triangles have that.
No. Well,
None of
yes.
the triangles have 0.
None of the angle has that, but you can think of the unit circle with the tangent line.
-1 or something? I don't know.
No, when tangent equals to 0, it's that value there. Which angle gives you tan
0,
equals to
0.
0, yes.
0 minus 0.
Hmm?
Yeah, yeah.
No. It's 0 because tangent of the 0 degree is also 0, right?
Okay.
Or 0 radian is also 0 because 0 degree or 0 radian is just that angle there. It doesn't move anywhere.
Yeah.
So it cuts the tangent at 0.
Okay.
So tan 0 is 0. Okay?
Cool.
So yeah, so that would just be pi on 8.
Okay. Wait, oh, yeah.
Okay?
Yeah, yeah.
Yeah. Now, last one, C. Antiderive from 0 to 1 of 3 over square root of 9 minus 4x squared dx. Alright. Can we antiderive it?
No.
No. Why?
You gotta take out 1 on 3.
No.
Make it 1.
No.
I don't know.
Think. What's the formula?
Oh, yeah, it's because you gotta isolate.
What part of that formula, what part of that thing there is a problematic
You
one?
got the 4. You gotta get rid of that.
You gotta get rid of it. So I'll show you the steps in this one, but yeah, you need to do it yourself later. This one, so first will be 0, 1, right? And then that will be 3, right? And then you take out 4, that will be square root of 4 times square root of what?
9 on 4.
Yeah,
Minus x squared.
yeah, good. Okay, dx.
And 2, and then do you like flip it?
9 on 4 minus x squared
Yeah.
dx. Okay, okay.
Yeah.
And what should the top be?
Top should be 1.
It should be 1, yeah. Okay, and then, so what do we do?
Take out the 3.
Yeah, we'll take out the 3 and also the 2.
So you go 1 on 2 times 1 on 3.
It's not 1, so it's 1 on 2 times what?
3.
Times 3, yeah, because 3 is on top.
Yeah, just take
So that should be 3 on 2.
3 on 2. Yeah.
Alright, and then that'll be 1 over square root of 9 on 4 minus x squared dx.
Yeah.
Okay, now can we antiderive it?
Yeah.
And that's from 0 to 1. So that would be what?
3 on 2, and then minus cosine,
Sine.
Positive.
Inverse sine, right?
Yeah. And then 4x on 9. Oh, no. 2x on 3. 2x
Yeah, 2x on 3, yeah. Watch out, your a is square root again.
Yeah.
Make sure you watch out for your a's, okay? Alright, and then that will be 3 on 2 inverse sine of 2 on 3
minus 0.
minus inverse sine of 0.
Yeah.
Okay, what's the inverse sine of 0?
0.
0, so it'll just be this thing. And can we calculate inverse sine of 2 on 3?
Probably.
Probably not. So calculator, you get whatever answer in the calculator. Okay, or if you take 3, you just leave it at that. Okay? Yeah, that's it. As I said, it's the fraction algebra that's tricky. The more you practice, the easier it will come.
Yeah. At least it's understandable.
Yeah, understandable so far, right?
Yeah.
Yep, so that's how many? That's 8 pages of notes, right? An hour of recording. So I will stop the recording now because I think you just need to go back and practice, basically practice all of this.